Very good day to all of you. Okay, today we are going to learn the inverse unit step functions. Okay, as you have learned that the Laplace transform for ht minus a, means for the unit step function, is exponent negative as over s. Hence, the inverse inverse Laplace of exponent negative as will get back ht minus a. And then for the second shift property, we have learned that the Laplace transform for ft minus a ht minus a is equal to exponent negative as, okay, Laplace transform for ft, which is the fs. Hence, the inverse Laplace transform of exponent negative as, fs, will be equal back to ft minus a ht minus a. In given case, the inverse Laplace of exponent negative as fs, okay, identifies your fs. Okay, from fs, takes the inverse Laplace of fs, then you get your ft. Then the inverse Laplace of exponent negative as fs. Okay, from ft, they obtain t, you change it to t minus a, and then multiply by ht minus a. For example, case 1. Finds the inverse Laplace of exponent negative 4s over s squared. Okay, so the fs, okay, notice that is in the form of exponent negative as fs, okay, where the a is actually 4, identified back, a is 4. Hence, okay, the inverse Laplace, you should have the ft minus 4, ht minus 4, because you identify your functions fs, a is 4, so the result is the ft minus 4, ht minus 4. To get your ft minus 4, you must get your ft first. To get ft, you must get your fs. Okay, fs is 1 over s squared. So in inverse Laplace of 1 over s squared, you get t. Hence, ft minus 4 will be t minus 4. That's why the result is actually t minus 4, ht minus 4. And the inverse Laplace of 6 exponent negative 2s over s squared plus 4, using the second shift property, and then identify a here is actually true. So means your answer will be ft minus 2, ht minus 2. Okay, and then you need to, before you can identify ft minus a, you have to identify your fs, which is 6 over s squared plus 4. Taking the inverse Laplace of 6 over s squared plus 4, you get ft, which is 3 sin 2t. That's why ft minus 2 means the t here, make sure a bracket, change it to t minus 2. That's why the result, for inverse Laplace of exponent the inverse Laplace of this one, 6 exponent negative 2s over s squared plus 4, will be your ft minus 2, which is 3 sin 2 times t minus 2 multiply ht minus 2. Okay, the third example finds the inverse Laplace of s exponent negative s over s squared plus 9. To apply the second shift property, we note that a is actually 1. So hence you need to find the inverse Laplace of this function to be ft minus 1 multiply ht minus 1. To get ft minus 1, first of all you must get your fs, and then take it inverse Laplace of fs and you get your ft. So fs you compare is actually the s. This is the fs. S over s squared plus 9. Taking inverse Laplace of the fs, you get this is cos 3t. So ft minus 1 means t, change it to t bracket t minus 1. That's why the result for the inverse Laplace of this will be cos 3 times t minus 1 multiply ht minus 1. Okay, similarly, for example 4, which consists of 3 terms, finds the inverse Laplace for the ft. If the Laplace of our ft here is 3 over s minus 4 exponent negative s over s squared plus 5 exponent negative 2s over s squared, find ft, means taking inverse Laplace of the fs. Okay, the inverse Laplace for the first term 3 over s, you easily can get 3. Okay, for second term and third term, you need to apply second shift property. Because you have in the form of exponent negative as fs. The inverse Laplace, the result is ft minus a ht minus a. So you either compare here. So the fs will be 4 over s squared. Ft is inverse Laplace of 4 over s squared. You get 4t. Okay, and then the inverse Laplace of exponent negative 4s fs, the result is ft minus 4 ht minus 4. A is 1, so it is ft minus 1 ht minus 1. So that's why, okay, you want to get ft minus 1, t here, bracket t minus 1. That's why this one, the result ft minus 1, which is 4 times t minus 1 multiply ht minus 1. The third one is the inverse Laplace of 5 over s squared. The third term, 5 over s squared exponent negative 2s. Similarly, okay, your fs, you compare here, this will be your, okay, compare this one with the second shift, okay, from property. So the fs is 5 over s squared, ft, you have 5t. And then here, you compare exponent negative 2s with exponent negative as, hence a is 2. A is 2. So the result is ft minus 2, ht minus 2. So ft minus 2, t bracket t minus 2. So that's why the inverse Laplace for this k function will be the ft minus 2, which is 5 times t minus 2 multiply ht minus 2. This is the third term. Then we combine, okay, the first term, just now inverse Laplace, we get 3. Okay, this is the second term, where we get here, second term, negative, because it's minus that term. So minus 4 times t minus 1, ht minus 1. Okay, the third term is, plus, so plus 5 times t minus 2, ht minus 2. Okay, to plot the graph, is it they want to plot the graph? Find ft. Okay, if the question find ft, you may stop here, but sometimes they want you to write the answer in the unit step function. In the step function. Because in the step function, then okay, the callbacks, it's here, I think, here, this one. You have now is actually ft is f1 plus f2 minus f1 ht minus a plus f3 minus f2. You are in the unit step function, we want to change back to step function because sometimes you may need to plot the graph of the function ft. So this is the f1. F1 is 3. Okay, this term is actually, your here. Let's refer here, f2 minus f1 equal to, expand here, equal to 4 minus ft, 40. Expand the negative 4. So this term is actually f2 minus f1. F2 minus f1, ht minus a, where the a is 1 here. And then to get the f2, plug in the f1, which is equal to 3. F1 is 3, so minus 3 bring to the other side, so plus 3, so 4 plus 3 is 7, so F2 is 7 minus 40. Okay, and then this one is actually F3 minus F2. f3 minus f2 ht minus b. A here, b here. So f3 minus f2, you have this phi t minus 10, phi t minus 10. Plug in the f2 minus f2, bring to the other side. This is actually your f2 plus minus f2, bring to the other side, plus f2, which is 7 minus 4t. So phi t minus 4t, you have t, minus 10 plus 7, you have minus 3. So this is f3. So put back f1, f2, f3. Okay, for f1, 0 less than equal to t. Okay, so you have ht minus 1. So make 1, 1. This is equal. And then you have the second one, ht minus 2. So look at it. This is 2. This is b greater than equal to 2. So if you want to plot the graph from t 0 to 1, the function's value is 3. Okay, and then to plot the second function, this is linear function, may substitute when t equal to 1, 7 minus 4, the value is 3. This is when t equal to 1. Okay, and the ending point when t equal to 2, so 7 minus 8, okay, is negative 1. So connect it, because this is a linear graph, connect it with a straight line. Okay, when t greater than equal to 2, 2 minus 3, you have negative 1. So this one is continuous function. And then, okay, the other point, let's say I plot until t equal to 5. So 5 minus 3, you have 2. So the example 5. If ft equal to the inverse Laplace of this function, find ft and sketch the graph of ft. So first of all, we expand the fs. Okay, expand it. So you have 1. Exponent negative 4s here. So this is minus exponent negative 2s. And then minus exponent negative 2s times exponent negative 4s total is minus exponent negative 6s over s squared. Okay, so we can notice that, okay, for this fourth term, their function fs is actually 1 over s squared. So in order to apply the second shift property, because you notice that it's in the form of inverse Laplace of exponent negative as. Okay, for second term a is 2, third term a is 4, fourth term a is 6. However, the fs is common, which is 1 over s squared. Once the inverse Laplace of exponent negative as fs, the answer is ft minus a, ht minus a. Means for second term, okay, you should have, okay, multiply with ht minus 2, third term ht minus 4, fourth term ht minus 6. Okay, and then the ft for 1, 2, 3, 4 are actually same. Only the first one, the inverse Laplace of, okay, 1 over s squared, you have t. So mean the first term, the result, okay, is t. Okay, second term is t minus a. For second term a is 2, so is t minus 2. T minus 2 times ht minus 2. Because first term with inverse 1 over s squared, I have t. Okay, second term is actually you need to apply second shift property, where the fs also 1 over s squared, and the ft is, okay, ft you get t, and second term is multiplied by exponent negative 2s. The result is ft minus 2 multiply ht minus 2. So ft minus 2 here, t you change to t minus 2 times ht minus 2. So similarly, the third term will be t minus 4, ht minus 4. The fourth term, t minus 6, ht minus 6. Then so you have t minus, because the second term is negative. So minus t minus 2, ht minus 2. The third term is positive, so plus t minus 4, ht minus 4, the bottom is minus, so minus t minus 6, ht minus 6. Okay, and then callbacks, sorry, this one, okay, second term here, this your g2 minus g1, this g3 minus g2, if you have one more, will be g4 minus g3. Once, okay, here, to sketch the graph, we need to change the unit step functions here to step function. So this is the f1, f1 equal to 2. Okay, here is your f2 minus f1. So f2 minus f1, okay, expand your negative in, so it's 2 minus t. To get f2, okay, minus negative 1, bring to the other side, become plus f1, which is t, so plus t. So 2 minus t plus t, we get 2. Okay, we obtain f1, f2, and this one will be f3 minus f2. So f3 minus f2 equal to t minus 4. Okay, you want to get f3, so the minus f2 bring to the other side, become plus f2, which is 2. So t minus 4 plus 2 become t minus 3. So this is the f3. Okay, and then this is actually the f4 minus f3. So f4 minus f3, so you expand negative in, so this becomes 6 minus t. To get f4, okay, minus f3 bring to the other side, become plus f3, which is plus f3, which is t minus 2. So 6, okay, minus t plus t, this one cancel, so 6 minus 2, we have 4. Okay, put back, okay, f4 is 4, f3 is t minus 2, okay, f2 we get 2 here, f1 is t, okay, and you have ht minus 2, ht minus 4, ht minus 6. So it's, okay, all here is less than or equal, so ht minus 2, so 2 here connecting, ht minus 4, 4 connect here, ht minus 6, this is 6, this t greater than or equal to 6. Okay, to sketch the graph, 0 to 2, the function is t, linear graph t. So when t is 0, ft is 0, when t is 2, ft is 2. Okay, from 2 to 4, when t 2 to 4, the function is actually 2. Okay, let's see. When t greater and equal to 6, the function is 4. Then to get the third function is a linear function. You may substitute both endpoints. When t equal to 4, 4 minus 2, you have 2. Okay, when t equal to 6, 6 minus 2, the value of y is 4. So this is the graph. Okay, in this case, thank you for your attention, and watching this video.